there is a volcanic eruption in Auckland and people need to shelter in place, these types of tests give us some insight as to what level of protection New Zealand buildings may give us. One of the things that we're increasingly understanding as natural hazard risk scientists that we need to understand is the multiple hazards that can occur in a volcanic eruption or an earthquake or whatever. So if we've got a good understanding of where there's been ashfall and then there's ballistics and how they may interact and whether they increase or decrease the vulnerability of a building, that's really important information. So rather than sort of taking it from a sort of single static test, understanding what that compounding impact could be or the cascading nature of that impact, that's really useful for making good decisions.
So this is a section of roof that we've built following New Zealand building code, and we're going to conduct experiments on it to see what kind of impacts we get from volcanic ballistic projectiles. We've also loaded it up with tephra, which is a finer grained product from eruptions or ash, and we're going to be using that to cushion the impact from the ballistic projectile. So we're using compressed air to create a vacuum and raise this rod up, which will lock in under our trigger. We can attach the rock then to the end of the rod, and when we fire and release the trigger, the rock will be pushed down onto our roof.
So with these tests, if we're able to understand what the impacts of these volcanic hazards are on specific New Zealand designed buildings, built to New Zealand building codes, that provides us much more understanding of what the potential rebuild or repair costs may be. But it also provides us with an understanding of how much shelter or protection that they may give us.